All right, continuity and one-sided limits. Okay, continuity, in order to think about continuity, you have to think about all things that are discontinuous, or yeah, discontinuous is what I'm wanting to say. Okay, and so there's all kinds of discontinuity. Okay, so let's say, for example, that you have a line and it goes on forever in both directions, but then all of a sudden you get to a point, you get there, and you get this hole. Okay, and this is called point discontinuity. So in other words, you have a hole there. So point discontinuity. Okay, and that's a huge issue. So we don't want point discontinuity because f of x is undefined at, let's call that a. Okay, and a would be the actual point of it. So a would be right there. Okay, so that's a huge issue. Okay, when you have those type of things. You also have jump discontinuity. Okay, so if I have my function, it looks something like this, and then all of a sudden I have, you go from here, and then all of a sudden it starts down here. Let's say that it's a closed-in circle. Okay. This one is called a jump discontinuity. And I know some of you guys are probably thinking, oh, but that is continuous because I'm not interrupting the values. Yes, and we're going to talk about the definitions of them real fast. The definitions of continuity. Okay, and then one final one, which is everyone's favorite, rational functions. Okay, so rational function looks like this. Okay, and we call this an infinite discontinuity. Okay, so it's where you're not doing it. I like to think of continuity as, can you take your pencil and draw the entirety of the graph without having to pick up the pencil to draw the other part. And in each one of these parts I have to pick it up at one point or another. Okay? Rules of... And I'm going to look up continuous functions. Okay, I'm going to look up the rules for continuous functions just to make sure I cover everything, because there is 3 rules that you need to be able to follow, because if you do that, you should be good. Okay, so there are 3 rules. Ah, come on. The internet's acting really slow today. Just sucking it up. Okay, so a function is said to be continuous Okay, let's go to the next slide. A function is said to be continuous at x equals a, and this one we're going to have to type in the limit. If the limit as x approaches a of f of x is equal to the function as if I plugged in that number a. Okay, so it's said to be continuous. Alright, and a function is said to be continuous on the interval a, it'd be if it is continuous at each point on the interval. Okay, so in other words, it's continuous at a certain point if my limit also equals that same point. And that covers for these types of graphs. Like, let's say we had a parabola right here, and we were like, okay, la la la, I have my graph and stuff. And then all of a sudden, we have a hole right here, and then all of a sudden at A, let's say that this was point A for this one, okay, all of a sudden I jump up. So normally I would say, okay, this function is continuous if it wasn't for that one spot. So I can say it's continuous from here to here and from here to here, but it's not continuous at that one spot. So it's discontinuous at one spot. So when you're looking for continuity, you want to look for also the domain and see what the domain is going to be, so you can get that type of stuff. All right, and also one-sided limits help out because they help us find the limits. Is there a limit here? Okay, so let's go ahead and draw something. Okay, let's say it was something funky that looked like this. Okay, now let's say I wanted to check to see if it was continuous at this point. Okay, so my limit is I would look to see my right-handed limit, and I would call this A plus. I'm going from the right-hand side, is that let me finish writing out the notation so you can see. So the limit as x approaches a from the right-hand side, I'll see if it approaches the same thing. And I'm going to do also the same thing from the left-handed side. So the limit as x approaches a from the negative side, from the right-hand side, that's what the negative part means. Okay? All right, we're going to see if they approach the same number. And we want these two to be equal. So don't get any ideas about this. We're looking for equality between these two. So if these two are equal, in other words, the graph looks like this, then you have a limit pretty much. Now, if we were doing it here, if we were doing the one-sided limit here, we would say, oh yeah, they're approaching the same thing. But then all of a sudden it equals a different number, so the function equals a different number. So there's three things that have to happen. The limits have to be the same, or sorry, there's two things. The limits have to be the same for approaching from both sides, and I need to have a value here. If I have a value here, I'm good. If I don't have a value here, I'm not good. And plus, that value needs to equal the limits. So these need to be equal, these need to be equal, and then these need to be equal, and this needs to exist. Okay, if we have that, we can start talking about taking limits. Okay, and we can start talking about continuity. Alright, so that's it for one-sided limits and functions. I will talk to you guys later, and you have a wonderful day. Thanks.